5 seconds on Mercury would be enough to destroy your spacesuit, boil parts of your body, and expose you to radiation stronger than anything humans face in Earth orbit. And that's before the real danger even starts. Mercury is the closest planet to the Sun, yet it isn't the hottest in the solar system. And that strange contradiction hides some of the most violent conditions imaginable. Today, we're going to drop a human onto Mercury's surface for exactly 5 seconds and break down, second by second, what would actually happen to your body, your suit, and your survival chances using real planetary science, NASA data, and physics. Because the truth is far more terrifying than Hollywood ever showed. Mercury looks simple from afar, gray, cratered, lifeless. But up close, it is one of the most extreme worlds in the solar system. NASA's Messenger spacecraft revealed that Mercury has almost no atmosphere, only a super-thin cloud of atoms called an exosphere, experiences temperature swings larger than almost any other planet, is constantly bombarded by solar radiation and micrometeorites, has gravity only 38% that of Earth. Source: NASA Planetary Fact Sheet, https://science.nasa.gov/Mercury. Standing on Mercury is less like standing on Mars, and more like standing in open space on a sun-baked frying pan. And that becomes deadly very quickly. On Mercury's daytime side, surface temperatures reach 430 degrees Celsius to 800 degrees Fahrenheit, hot enough to melt lead, hot enough to destroy exposed electronics, hot enough to cook most spacecraft surfaces over time. But on the night side, minus 180 degrees Celsius to 290 degrees Fahrenheit, cold enough to freeze carbon dioxide solid, cold enough to turn exposed skin brittle in moments. These insane swings happen because Mercury has almost no atmosphere to trap heat. Source: NASA Mercury Facts, https://science.nasa.gov/Mercury/facts. So already, the question becomes, which side did you land on? Because your 5-second fate depends on that. Let's assume you teleport onto Mercury's sunlit surface, the worst-case scenario. The moment your boots touch the ground, 4 things hit you simultaneously: near vacuum pressure, extreme solar radiation, blinding sunlight, scorching terrain beneath your feet. Without a spacesuit, you wouldn't even last 1 second. In vacuum, the human body loses oxygen immediately. Saliva and moisture on your tongue begin to boil, a process called ebulism. Blood doesn't explode like in movies, but oxygen starvation causes unconsciousness in about 10 to 15 seconds. Source: NASA Human Exposure to Vacuum, https://neetrs.nasa.gov. So, 5 seconds bare-skinned? You'd still be conscious, but already suffocating, while heat and radiation tear into you. But let's be generous. Let's say you're wearing a futuristic spacesuit. Now, things get slightly slower. Modern NASA suits like the EMU or Artemis XMU are built for Earth orbit moon operations. Temperatures around minus 150 degrees Celsius to plus 120 degrees Celsius. Mercury's sunlit surface is far hotter than that upper limit. In 5 seconds, the suit's outer layers begin absorbing enormous heat flux from solar radiation, almost 10 times stronger than Earth orbit. Thermal radiation bouncing off the surface, conductive heating through your boots. Source: NASA Solar Constant Data, https://science.nasa.gov/solar-system/sun. Mercury receives about 6.5 times more sunlight than Earth. That energy slams into every square meter of your suit. Cooling systems would struggle immediately. electronics inside the backpack life support unit begin overheating. Your visor polarizes to protect your eyes, but glare from the sun is brutal, unfiltered by atmosphere. You can barely see. Earth protects us with two shields: a thick atmosphere, a powerful magnetic field. Mercury? It has only a weak magnetic field and almost no atmosphere. That means ultraviolet radiation. X-rays, solar particles, slam into the surface almost unhindered. NASA instruments measured intense particle bombardment during solar storms. Source: NASA Messenger Mission, https://www.nasa.gov/mission_pages/messenger. 5 seconds won't give you radiation sickness, but the dose rate is frighteningly high. Your suit's shielding works over time. And then there's something worse. The biggest killer on Mercury isn't just heat. It's the speed at which everything becomes uncontrollable. Cooling systems fail. Electronics degrade. Pressure seals weaken. And the sun keeps blasting energy into you non-stop. You're not standing on a rock. You're standing on a planet that is trying to bake you. And you only have 5 seconds before something critical gives way. Mercury's soil, regolith, is superheated, powdered rock. Your boots are touching a surface glowing in infrared. Heat begins conducting upward through the soles. Inside your suit, temperature alarms start flashing. Meanwhile, Mercury's gravity is weaker, so every movement feels bouncy. But that doesn't help much when survival time is measured in heartbeats. And hovering invisibly around you? Micrometeorites. Because Mercury has no atmosphere to burn them up, tiny particles strike the surface constantly at cosmic speeds. NASA confirmed this ongoing bombardment reshapes the planet over millions of years. Source: NASA Mercury Geology, https://science.nasa.gov/mercury/geology. A grain of sand traveling at tens of kilometers per second could puncture layers of insulation. 5 seconds is short, but not zero. Now, let's flip the scenario. Suppose you appear inside a crater near Mercury's poles, permanently shadowed regions where sunlight never reaches. Temperatures there stay below, -170 degrees Celsius, so cold that water ice can survive for billions of years. Yes, Mercury has frozen water. NASA confirmed ice deposits using radar and neutron spectrometers. Source: NASA Ice on Mercury, https://science.nasa.gov/mercury/water-ice. Here, instead of cooking, you start freezing. Suit heaters blast at full power. Lubricants thicken. Batteries drain faster. Metal contracts. 5 seconds here won't kill you outright. But you're racing against hypothermia instead of incineration. On Mercury, every location is lethal, just in different ways. Let's return to the sunlit side. 5 seconds have passed. Your suit's cooling system is overloaded. Thermal sensors are screaming. Radiation counters tick upward. Your boots are dangerously hot. If you stayed another minute, internal temperature would rise. Electronics could fail. Pressure systems weaken. A visor crack or coolant rupture becomes catastrophic. At that point, vacuum exposure plus solar radiation plus extreme heat equals death in seconds. Mercury doesn't give warnings. It gives deadlines. And you just hit yours. So what really happens if you spend 5 seconds on Mercury? Without a suit, you suffocate and begin boiling in vacuum. With a modern suit, you survive briefly, but systems overload fast. Heat or cold attacks you immediately depending on location. Radiation exposure is extreme. Micrometeorites pose constant risk. Staying longer than minutes with current technology is impossible. Mercury isn't just close to the sun. It's one of the most hostile surfaces humans could ever attempt to stand on. 5 seconds? That's survivable only with advanced gear. Anything longer, and Mercury wins. And don't forget to hit subscribe for more unraveling mysteries like this. 5 seconds on Mercury.